Imagine waking up in a brand new house that spent only a few hours at its final address. It sounds impossible, but some of the world's most advanced homes arrive almost completely finished before they ever touch their foundations. While traditional houses may take 6 months or even a year to build, a modular home can leave a factory up to 90% complete with kitchens, bathrooms, wiring, plumbing, and even paint already finished. Today, you're going behind the factory walls to witness one of the greatest manufacturing revolutions transforming modern construction. Think about this. Instead of hundreds of workers battling rain, wind, freezing temperatures, and delays, everything happens inside a climate-controlled factory that stretches longer than several football fields. Giant assembly lines move entire houses instead of cars, while hundreds of specialists work in perfect sequence. The sounds of nail guns, robotic saws, forklifts, and overhead cranes echo through the building, creating an industrial rhythm unlike anything most people have ever seen. But here's what nobody tells you. A modular home isn't just built faster. It often achieves tighter construction tolerances than many houses built entirely on-site. Powerful computer-guided machines cut every beam with millimeter precision, while inspectors examine thousands of individual details before each module can leave the factory. And this is where our journey becomes truly extraordinary, because every perfect home begins with raw materials that have traveled across continents. Most people only see the finished house. They never see the forests, steel mills, insulation plants, and glass factories working together behind the scenes. By the end of this journey, you will understand why building an entire home inside a factory may become the future of housing around the world. But first, we have to travel back to where every wall, every roof, and every floor begins. Every modular home starts deep inside carefully managed forests. In North America, large volumes of structural lumber come from sustainably harvested forests in Canada and the northwestern United States. Scandinavian countries like Sweden and Finland also supply high-quality spruce, while Central Europe contributes precision-engineered timber products. Every harvested tree gets replaced through managed forestry programs designed to keep forests productive for generations. The journey has only begun. Freshly cut logs weighing between 500 and 2,500 kilograms travel hundreds or even thousands of kilometers by truck and rail before reaching giant sawmills. Their automated scanners inspect every log in seconds, searching for knots, cracks, and hidden defects before computer-controlled saws slice each trunk into perfectly measured boards. The scent of fresh pine fills the air while mountains of sawdust swirl through powerful extraction systems. What happens next surprised even experienced engineers. Fresh lumber contains as much as 50% moisture, making it unstable for precision construction. Massive kiln dryers gradually reduce that moisture to roughly 15% or less using temperatures between 60 degrees Celsius and 90 degrees Celsius, or about 140 degrees Fahrenheit to 194 degrees Fahrenheit. Without this careful drying process, finished walls could twist, shrink, or crack years after the home is completed. Wood alone cannot support a modern modular home. Structural steel arrives from mills that transform iron or mined in Australia, Brazil, Canada, and Sweden into incredibly strong beams and connectors. Inside electric arc furnaces, recycled steel scrap and virgin steel melt at temperatures approaching 1,600 degrees Celsius, or about 2,912 degrees Fahrenheit, creating materials that hold entire buildings together through storms, heavy snow, and earthquakes. Then comes one of the quiet heroes hidden inside every wall: insulation. Manufacturers transform recycled glass, volcanic rock, or natural sand into insulating fibers by heating raw materials to more than 1,400 degrees Celsius, nearly 2,550 degrees Fahrenheit. Powerful spinning machines stretch the molten material into millions of microscopic fibers that trap tiny pockets of air, helping homes stay warm during freezing winters and cool under blazing summer sun. Glass follows an equally remarkable journey. Manufacturers blend silica sand, soda ash, and limestone before melting the mixture at roughly 1,550 degrees Celsius, or 2,822 degrees Fahrenheit. The glowing liquid floats across a bath of molten tin, producing perfectly flat sheets that later become energy-efficient windows capable of reducing heat loss and outside noise. Every clear pane began as ordinary sand before engineering transformed it into something extraordinary. Inside the walls, hundreds of meters of copper wire and plastic plumbing quietly wait for their moment. Copper often begins its journey in giant mines across Chile, Peru, the United States, and Australia before refiners produce metal that reaches more than 99.9% purity. At the same time, high-density plastic pipes made from petroleum-based polymers travel from chemical plants, ready to deliver clean water through every room of the future home. By the time every beam, window, wire, screw, cabinet, and roof panel finally arrives at the factory, a single modular home may contain materials sourced from more than a dozen regions around the world. Thousands of individual components now wait with perfect timing, because one delayed shipment can stop an entire production line. And what happens when every one of those pieces finally comes together inside the factory is even more astonishing than the journey that brought them there. The moment every material reaches production line, the real transformation begins. Unlike a traditional construction site, where workers move from house to house, here the house moves from team to team. Massive steel rollers slowly advance each module through the factory at roughly 1 to 3 meters per minute, allowing hundreds of specialists to perform their tasks in perfect sequence. The air fills with the sharp crack of nail guns, the hum of electric motors, and the constant beeping of forklifts weaving between towering wall sections. Everything starts with the floor. Automated framing tables position kiln-dried lumber with incredible accuracy before high-speed nail bridges drive hundreds of galvanized nails into place. Pneumatic nailers operate at air pressures between 90 and 120 psi, fastening joints in fractions of a second. Laser measuring systems constantly verify every dimension, keeping structural accuracy within about 2 millimeters across an entire floor module that may stretch more than 15 meters long. Now the walls begin to rise. Computer-controlled saws spinning at nearly 4,000 revolutions per minute cut every stud with millimeter precision before robotic positioning arms hold each piece exactly where it belongs. Teams of carpenters secure the frames while the smell of freshly cut pine mixes with the scent of engineered wood adhesives. In only 20 to 30 minutes, an entire exterior wall stands where loose pieces of lumber sat just moments before. But a wall without strength cannot protect a family. Sheets of structural plywood or oriented strand board move into hydraulic presses that apply several tons of force, while industrial adhesives cure under carefully controlled temperatures of around 20 to 30 degrees Celsius, or 68 to 86 degrees Fahrenheit. As thousands of nails lock the panels together, the entire structure becomes rigid enough to withstand powerful wind loads and transportation over public highways. What happens next surprises almost everyone. Electricians and plumbers enter walls that still have no drywall, carefully routing hundreds of meters of copper wiring, communication cables, water lines, and drainage pipes. Every wire follows strict electrical codes, while every pipe undergoes pressure testing at approximately 100 to 150 psi before anyone seals the wall. If even one fitting leaks, the entire section returns for repair before production can continue. Next comes the invisible shield that makes modern homes comfortable. Thick insulation fills every cavity, eliminating gaps where heat or cold could escape. Workers carefully install vapor barriers before precision-cut drywall panels glide into place, transforming exposed framing into recognizable rooms. The factory grows quieter as soft white walls replace the maze of wooden studs that dominated the assembly line only minutes earlier. Then the house suddenly begins to feel alive. Factory crews install cabinets, countertops, flooring, doors, windows, bathroom fixtures, lighting, and even complete kitchens while the module remains safely indoors. Paint dries under carefully controlled temperatures near 21 degrees Celsius or 70 degrees Fahrenheit, with humidity closely monitored to ensure a flawless finish. Instead of battling rain, dust storms, or freezing weather, every worker operates under ideal factory conditions that dramatically improve consistency. Outside, another team prepares a roof. Giant roof trusses arrive fully assembled before overhead cranes capable of lifting several tons gently lower them into position. High-performance roofing membranes, weather-resistant panels, and precision-fastened shingles create a shelf strong enough to survive years of rain, snow, hail, and scorching sunlight. Every connection must remain perfectly aligned because the completed module will soon travel hundreds of kilometers by truck. Before leaving production line, each module undergoes an extraordinary transformation. Protective wrapping seals every window, door, and finished surface against weather during transport. Hydraulic lifting systems gently raise modules weighing anywhere from 20 to 80 tons before specialized transport trailers slide underneath with astonishing precision. The entire building, once nothing more than raw timber and steel, now waits for a journey that few houses will ever experience. You might think the hardest part is over, but this is where the greatest challenge begins. Before a single family can move in, engineers must prove that every wall, every wire, every pipe, and every structural connection meets some of the toughest standards in modern construction. The next stage pushes these homes to their limits, and not every module survives the inspection. As each completed module rolls into the inspection hall, the atmosphere changes instantly. The thunder of nail guns fades, replaced by the quiet hum of laser scanners and computer servers analyzing thousands of measurements every second. Most people assume the house is finished, but experienced engineers know the real test has only just begun. One tiny defect hidden behind a wall could become a costly problem years later, so nothing escapes inspection. The first inspection begins with geometry. High-speed 3D laser scanners sweep across every wall, ceiling, and floor, creating a digital twin accurate to within about 1 millimeter. Advanced software compares millions of measurement points against the original computer design in just a few minutes. If a wall leans even slightly beyond its tolerance, the system immediately alerts inspectors before the module moves forward. Next comes one of the most demanding challenges, a pressure test that reveals leaks invisible to the human eye. Giant blower door fans temporarily seal the home and create a pressure difference of roughly 50 pascals between the inside and outside. As air rushes through the structure, thermal cameras reveal even the smallest draft around windows, doors, and utility penetrations. What feels like solid construction suddenly exposes every hidden weakness in brilliant shades of red, yellow, and blue. Water systems face equally unforgiving tests. Every plumbing circuit fills with water or compressed air before technicians raise the pressure to approximately 150 psi and hold it for up to 30 minutes. Digital sensors continuously monitor for even the slightest pressure drop. A single leaking fitting, no matter how small, sends a module back for immediate repair, because once the home reaches its destination, those pipes will hide behind finished walls. Electricity receives the same level of scrutiny. Automated testing equipment checks thousands of wiring connections, verifies grounding systems, measures insulation resistance, and confirms every outlet delivers a correct voltage. Computers complete many of these tests in seconds, but licensed electricians still perform detailed visual inspections because they notice subtle installation issues that software can overlook. Even in one of the world's most automated factories, human experience remains impossible to replace. Then comes the structural examination. Engineers inspect every steel connector, bolt, anchor plate, and welded joint using digital torque tools and precision measuring instruments. Some manufacturers even use ultrasonic testing to search for hidden flaws inside critical welds without cutting the steel apart. The metallic clicks of torque wrenches echo through the inspection hall as every connection proves it can survive years of wind, vibration, and transportation. What happens next surprised even experienced engineers. Selected modules undergo simulated transportation tests that recreate the forces experienced during hundreds of kilometers on public roads. Powerful hydraulic systems gently flex the structure, while sensors measure movement down to fractions of a millimeter. If cabinets rattle, drywall cracks, or windows shift, engineers redesign the structure before full-scale production continues. Behind the scenes, artificial intelligence now plays a growing role in quality control. AI vision systems study thousands of high-resolution images every hour, identifying missing fasteners, paint defects, surface scratches, and installation errors with remarkable speed. Some factories reduce defect rates below 1% by combining machine vision with experienced inspectors who verify every critical finding. Together, humans and intelligent machines create a level of consistency that traditional construction rarely achieves. Only after passing every inspection does the module receive its certification. Depending on the country, inspectors verify compliance with standards such as the International Residential Code, regional building regulations, electrical codes, plumbing codes, and energy efficiency requirements. Every approval label represents thousands of individual inspections performed throughout manufacturing. Without those certifications, the home never leaves the factory. You have now watched an entire house emerge from raw materials with astonishing precision, but one mystery remains. How many of these homes are built every year? Which countries lead the industry? And why do experts believe modular construction could transform housing over the next decade? The numbers are far more surprising than you might imagine, and they completely change the way we think about building the future. Now that you've seen how an entire house comes to life inside a factory, let's zoom out and look at the bigger picture. The global modular construction industry has grown into a market worth well over $100 billion US, with analysts expecting it to nearly double over the next decade as cities search for faster, more sustainable housing solutions. Every year, manufacturers produce hundreds of thousands of modular homes, classrooms, hospitals, hotels, and offices. Imagine entire neighborhoods taking shape not over years, but in a matter of weeks. Today, China leads the world in modular construction capacity, producing roughly one-third of global output thanks to its enormous manufacturing infrastructure. The United States follows with approximately one-fifth of worldwide production, while Japan, Canada, and several European nations continue to expand highly automated factories. Together, these regions employ hundreds of thousands of engineers, carpenters, electricians, welders, logistics specialists, and quality inspectors. Most people never realize that building homes has become one of the world's most advanced manufacturing industries. Think about how far this technology has come. In the 1970s, factory-built homes often carried an unfair reputation for lower quality because manufacturers relied on simple materials and limited automation. Today, computer-controlled machinery, engineered timber, structural steel, advanced insulation, and digital quality control allow many modular homes to match, or even exceed, the performance of traditional site-built houses. What once seemed like an alternative has become a serious competitor, and this is where the numbers become truly astonishing. Modern modular construction can reduce project timelines by 30 to 50%, lower material waste by as much as 80%, and significantly reduce weather-related delays, because nearly every stage happens indoors. Fewer wasted materials mean fewer truckloads heading to landfills, helping manufacturers lower both costs and environmental impact. Building smarter doesn't just save time, it also conserves valuable resources. Did you know that some luxury modular homes cost well over $1 million, complete with custom architecture, smart home technology, and premium finishes? Did you know entire hospitals have been manufactured in factories and assembled on-site in just a few months? And here's the biggest surprise of all. Engineers have even used modular construction techniques in some of the world's most remote environments, where traditional building methods simply aren't practical. Looking ahead, the next decade could completely redefine how the world builds homes. Artificial intelligence will optimize factory schedules, collaborative robots will assist skilled workers, and digital twins will simulate every stage of construction before the first beam is cut. New low-carbon concrete, recycled steel, and mass timber products promise even more sustainable buildings. The factory of the future may build entire neighborhoods with greater speed, precision, and efficiency than ever before. From towering forests and glowing steel furnaces to precision robots and meticulous quality inspections, you followed every step on an extraordinary manufacturing journey. What began as raw timber, molten metal, glass, and copper became a fully finished home capable of sheltering generations of families. Every measurement, every weld, every wire, and every inspection reflects thousands of hours of engineering experience working together behind the scenes. The next time you drive past a modular home, you'll know you're looking at far more than a building. You'll be looking at one of the most remarkable manufacturing achievements of the modern world. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.